Hello, welcome everyone. So, welcome to podcast by Samir Shurur, which is Tech Talk. Okay, and we are starting with Industry 4.0 Unplugged. So, what we are trying to do it in this podcast series is we are trying to break the Industry 4.0 jargon into more understandable formats and more readable formats to everybody, including professionals, owner operators, students, and everyone who is involved in this journey. Okay. So let's start with the purpose of this particular podcast. So what we are covering today is Industry 4.0 basics. So what is this basics? Basically, what we are going to deal with is we are going to deal with what is Industry 4.0. We are going to deal with origin of Industry 4.0. We are going to deal with from where it started, who made it more popular, its own journey. We will also see where are various technical components involved in Industry 4.0, and try to understand the overview of the technical components. We will also finally end with what is it status in India. What is the current adoption rate in India? Who has adopted? I mean, what sector has adopted better in terms of numbers, as well as what are the skills required and how what is our democracy talks about. So the idea is to understand these various aspects of Industry 4.0 as it stands to us, professional as well as a country. Now, when we talk about Industry 4.0, what is this? Basically, this is also known as a fourth industrial revolution. This talks about digitalization technologies, implementing them for manufacturing and related industries. So, what are these digitalization technologies we are talking about? These are basically Internet of Things, artificial intelligence, machine learning, cloud computing, big data, robotics, many more such technologies. We will go in depth in terms of understanding these technologies when we reach that part of the podcast. But take it for right now is that adopting these transformational technologies to our regular day-to-day problem solving for manufacturing as well as related industries is called Industry 4.0. Now, we started with Industry 4.0. Then what is this first, second, third, where it went, right? That might be some of the questions for generation which just started in the area or in the sector, and they are opening their eyes in the professional market. So let's break it up for them. The first one is industrial revolution. First industrial revolution talked about utilizing hydro power, steam power, and which came about in 1800. Okay, so there is where you called started with steam engines, right? A second industrial revolution generally talked about situation where first assembly line was established, making it a bulk mass production, I would say. And this is with the advent of electrical energy, which is in around 1900, start of end of 1800. End of 1800s. Okay, now third industrial revolution is basically automation of industry assembly line, I would say, where the production line was got automated. We saw a lot of machineries, programmable computers, CNCs within and around us in the manufacturing, as well as in the EPC sector. We saw a lot of CAD programming getting introduced in our own world, right? And fourth industrial revolution is basically cyberspace, digitally connected world. Now here what we are talking about is making people to machine machine to machine connection. So and it's across the wide area network, and this is not only limited to single factory site. It is connected to various factories across the world, various companies, various offices across the world. So this is where the fourth industrial revolution, embarked this journey on. But when we are researching, when we are talking to various vendors, various countries, continents, this industry 4.0 is called differently. Yes, that's true. Someone calls it fourth industrial revolution. Someone calls it smart manufacturing. Someone calls it cyber physical system, CPS revolution. Someone calls it connected industry. And someone calls it digital transformation journey or industry. At the heart of it, what everybody is talking is utilizing advanced technologies to connect to various offices horizontally and vertically. Okay, this horizontal vertical concept itself is one of the technologies in Industry 4.0. More on it when we reach there. So, if you hear all these names, please consider that all these are same things at the bottom of it. Okay, now let's understand who popularized it and what country is doing. I mean, which country is doing what regarding these technologies or these Industry 4.0 adoption. So, Industry 4.0 is a German term. Industries 4.0. Okay, originally coined by government, German government. The made China has a similar term, a similar initiative called Made in China 2025. Japanese have Society 5.0. I think in North America it is more on smart factories, if I am not wrong. So every major country has their own terms. By the way, India is still, I would say, calling it as adoption of Industry 4.0 or digital technologies, right? And I have never come across a research article which says this is the word which India is using. So if anyone comes across this, please share it with me and let's share with others. So these are huge countries. They have started a lot of investment in this area, and they have their own way of calling it. So for a professionals like us, the bottom line remains is adoption of all these interesting technologies to solve manufacturing related industries day-to-day problems and future problems by the way. So what is its history, right? So if you say Industry 4.0, did it did it suddenly dropped out of somewhere? No, it has its own evolution, I would say, in the last decade or so. So, to start with, in 2010 and 11, German government started with the product, just started with the project in 2010 and 11. This is formally introduced as a high-tech strategy by the German government, focused on promoting digitalization in manufacturing and integration of cyber physical systems into industrial process. And that is where a lot of European countries started talking about it, and a lot of papers started getting published around this topic. If you go into industry well-known research article libraries, you will get a lot of reports starting from 1011 with named as Industry 4.0. Next milestone, I would say, came in 2015-16, where Klaus Schwab, who is a founder of World Economic Forum and still very much active with young World Economic Forum group. He started popularized the term called Fourth Industrial Revolution. He has written many books and articles, bringing the concept to wider audience and sparking global discussion around this topic. Third major push to Industry 4.0 or adoption of these technologies came in 2020 and 2021. When world was leading in lockdown, industry was getting pushed by this pandemic to evolve, to transform and adapt. And that is where the relatively larger investments started flowing because of the foundational work done by a lot of these researchers and scientists found this transformation started happening in 2021. So if you research on the investment, there is a huge investment jump which happened between these three areas. These 3 years, starting from 10, 11, 15, 16, and 2021. So that is where I would say there's a this is how the industry 4.0 as a concept has evolved in three distinct phases. Now let's look at the technical components that are involved in industry 4.0. Let me share quickly a slide. I would let's see if it is possible for me, so that there is something on there on the screen when you guys are checking out. So let me share the slide. Great. Okay. So technologies involved in industry 4.0, as you can see, there are 9, 10, there is a debate, but let's stick to these 9 technologies that are part of these industry 4.0 whenever people are talking. Okay. Now let's go one by one and see. Okay, this thing is troubling me. Okay, good. So fine. So let's look at those technologies one by one and see how these individual technologies are stacked against each other or with each other to realize industry 4.0 implementation to us, manufacturing and related industries. So one interesting, I'll start with the augmented reality. Okay, that is the one which I'm going to start with. Let me make a laser pointer so that we all, so okay, so first I am talking about augmented reality. We have all played video games, right? We all gone to e-learning. Now what is it context with our industry? So there are two things in augmented reality. One is mixed reality and augmented reality itself. When you say mixed reality, this is basically merging of real and virtual worlds to produce a new environment and visual representation. Okay, this got real push according to me in my experience after the or during the pandemic. When you really wanted, you had to do the commissioning, but you have to sit in your office, right? You can't move freely around. But the technologies were already there. So basically what I'm talking about is you are superimposing your virtual world with the physical world, and you are instructing or taking actions in the physical world via virtual environment. That's the mixed reality. The second one is augmented reality, where basically the physical world is augmented and information objects are virtually added, right? Uh, and let's the third important is haptics. Haptics is a very new technology. I would not call it a new technology, but an interesting addition to this augmented reality. Basically science of sensing based on touch. So people with iPhone are more I think they are, if you go in your settings, you can see haptics written there. This is a lot of papers are getting published in this area, and specifically with remote operation of medical equipments, remote operation of robotics. These haptics is playing a lot of bigger role. So for learning enthusiasts and the futurists, I think I would recommend to go into this area. So we talked about two concepts: mixed reality and within the augmented reality, and haptics, right? So let's move on to additive manufacturing. So additive manufacturing, this is a classical example of 3D printing. I remember I got first introduced in this around 6, 7 years ago, and we were talking about 3D printing some plant, right? Some miniature plant. Now, that is where the interest started. But today, if you ask me, quite an advancement that is happening in additive manufacturing. It is not limited to 3D printing, by the way. It has a lot more, it is 3D printing, but a lot more complexities, interesting technologies implemented there. Okay. Uh, so in this 3D printing, additive manufacturing, I'll talk about three main technologies which users can further go review and study. First one I will talk about is sintering. So what is sintering? So sintering is basically additive manufacturing or creating a material without heating or without material being liquefied, or creating a complex material without making it liquid. So a lot of metal powders are used in this scenario, and use cases are in automotive industries, aerospace industries. When I look back in our own EPC and industrial world scenario, I think a lot of use cases are also there in building products such as materials such as walls, piping materials, bulk materials, where are small in unit. I think that is the use case I can see in using sintering. There are also okay. So this is the first one which I want to talk about. Second one is directed energy deposition technology. So here, what it does basically is the laser is used to melt the material or melt the powder, and these melted layers are added on each other to build the product, build the material. Okay. I think same here. I think electronic beams are used for power as a power source to melt the material. So this is one more use case to build, uh, bulk materials for our own industries. I can even say welding is also similar technique, but it has a challenge. You can't call it additive technology because there is a lot of surface preparation and surface finishing required in welding. But I am for our own industry, I am tempted to add this in additive manufacturing, right? So it's not a complete manufacturing, but yes, you can visualize the I mean production. That's why I am linking it. Now, third one is stereolithography. Uh, uh, this is basically a lot of made. Okay, so as a technology, what is this? Is basically ultraviolet light at the high energy is implemented on a vat of polymer photovoltaic polymer material. So it gives us shape, okay, in the space. So this shape typically can be the one you design in your CAD programming. So current industrial use cases are a lot of medical equipments, lot of beautification equipments are accessories are built on this, like diamonds or POCs of diamonds or jewelry items are built on this. But for our own industries, I would say if you are embarking on a very high costly projects, uh, like NEOM, right, multi-billion dollar projects or a multi-billion dollar refinery, I think you should put some investment in this technology, build an entire plant or units, and see how they are interlinked. This can be an interesting accessories for your own plant or project, I would say. I think learning can be facilitated with this kind of technologies. But personally, I would feel medical field is more suitable and more ROI based. Fantastic. Very detailed discussion on additive manufacturing. Let's move on to cloud. Everybody is I would say familiar with the cloud. Everybody is right from Google, Apple, everybody is talking about clouds, right? We are all storing our data on cloud. But the industrial context, if you see, we are talking about network of factories, network of offices. Gone are the days where we were worried about only cyber security. Yes, cyber security is important, which is coming as a next topic, but that should not be the criteria for not going into the cloud, because cloud is going to give us lot of off the shelf analytics, analytics on it, and high computing power is coming in cloud technologies. So I think this is a time where we all talk about going into cloud and explore or exploit the technologies available. And even the cloud service providers are doing a lot of good work, I would say, in terms of bringing in these network or providing the data anywhere, any device, anytime. Cyber security is an interesting and important topic. A lot of area, a lot of research are happening for managers, technology managers like us. It's important before we start adopting all these systems. Look at the risks involved, evaluate and advise the business to take right decisions. Hence, this is very important. Big data analytics. When you say big data analytics, so one mind-boggling number, you know how much data we are generating as a population? We are generating 120 zettabytes of data, which is 1 trillion terabytes, if I'm not wrong, which is very, very, very huge. Okay. And this number is going to go higher and higher. And biggest contributors in this are industrial plants. As a process industries, we have been generating data from hundreds of years, and we have been storing it in our databases, in our systems. Unlike other industries, we are storing our databases in quite a structured form, right? Yeah, it may not be the greatest structure, I would call it. It will still in silos, but still it is in electronic form, right? So we are at the cusp of utilizing this big data and analytics, which has, by the way, matured. If you go to Gartner survey, this is one of the matured industries, right? So all these process industry owner operators and people like technology, we need not be scared of dealing with this kind of data. There is a lot of skills available, technologies available. Okay. Next, I would like to move on to autonomous robots. Autonomous robots, I will spend quite a little time here, like our additive manufacturing. So, so robotics is also quite a evolving field. If you see automotive industry, if you see, I would say, discrete manufacturing areas, these are already playing lot of bigger role. They are in fact moving into cobots, right? I mean, they are talking about taking robots into their day-to-day operation and trying to solve their utilize and increase efficiency of the assembly lines. For construction industry, for a process and related industry, autonomous robots can also play a lot of areas, especially the newest robots with higher degrees of freedom, more than 6 degrees of freedom. These autonomous robots can play an interesting role. So some of the benefits, I would say, is a fully autonomous robot can gain information about the environment, work on an extended period without human intervention, move either all or part or itself throughout the operating environment without human assistance, avoid situations that are harmful to people, property, and itself without without compromising safety. And by the way, who people who are interested, there is first and second and third law of robotics, where you can clearly define how a robot needs to be designed and implemented. First, the instruction of human is important. Second, safety of human is important. Third, first two laws, without overtaking the first two laws, hurting the environment or itself, is the third law. Giving you a quick information, but what I'm trying to give you out of this is there is clearly defined laws. So again, we need not be scared. A lot of research is happening already, and we can take party to it. Now, before moving on to the next interesting part, I think you already realize, right? With kind of semi or autonomous robots, we are talking about a lot of use cases in construction. Something like progress monitoring, site safety monitoring, hazardous area review, for a process industry, and quality checking for a process industry, baggage, packaging, distribution, supply chain, logistic, huge potential, warehouse monitoring for autonomous robots in our industries. So I think, hope some of you are already implementing it, to be very honest. Next technology is simulation. I think I hope I'm not going fast. I don't want this podcast to be very long. So I am trying to cover the information and trying to give it a crisp information. So, okay, let's move on to the simulation. So simulation, so what is the simulation? This is, I would call, a cornerstone in industrial revolution. This is where this is broadly called as a simulation, but the cornerstone came in terms of digital twin or replication of physical parameters into virtual parameters. I think this is where the revolution came. I think started with NASA. I will not go in detail of what kind of digital twin and other in this scenario. Also, in this podcast, probably this is the area where I am working, and probably I'll come up with the next podcast on this digital twin in current market scenario. But this is an interesting and evolving field. I would say there are a lot of isolated digital twins, end-to-end digital twins that are already coming in the market. Kindly go through research materials and your own research on implementing evaluation these of digital twins in the market. Okay, and so next important is horizontal and vertical system integration. So uh, I think this is applicable to both EPC world as well as process industries. When we say horizontal and vertical system integration, horizontal integration is basically horizontal integration is basically going from a sensor level to ERP level, right? Sensor, then sensor to converter, converter to machine, machine to human machine, human machine. I hope you are getting the gist, right? Vertically, and then finally collecting to your ERP systems of the your factory and taking decisions based on the sensor that is happening at the production line. So I would call it a dynamic information flow within the factory setup. Similarly, if you look at EPC word scenario, engineering that is happening in the site, moving that information to construction and making sure that the ordering is happening as what is being designed and what is being constructed, right? So that's a interesting vertical I'm in trying to define here. Whereas vertical horizontal integration is basically, you for a process industry, you have logistic partners, you have vendors, you have multiple factories, connecting all this information at the highest level and trying to drill down at the lowest level, right? So this environmental collaboration or integration is called vertical integration, and there are interesting theories, use cases, research paper, and already lighthouse factories are great examples of these horizontal and vertical integration. You can go check out about this in the internet about lighthouse factories and World Economic Forum. And when I say EPC, same, there is nothing different, right? We have fabrication supporters, we have manufacturers, we have construction contractors, their offices. We have our own EPC, branch offices as well as workshare locations and owner operators. So if you really break it into horizontal and vertical use cases, we have an interesting use case around, and lot of companies are already doing it. The only thing is they are not packaging in the right way, probably, and then presenting it to us in our own EPC world. Okay, so last one is the industrial Internet of Things, IoT. I think everybody is an IoT, I would say. I don't think, I mean, I'm not saying as a human or a people like us, but everything what we are wearing today. If you are wearing a smartwatch, it is running on IoT. If I mean, we are talking about smart shoes today, right? Smart helmets. So a lot of IoTs around us, I would say. So basically, just to coin or give you an interesting or rather overview type of name. I mean concept. IoT is basically putting sensors, a microprocessor, microcontroller, embedding all these things on your physical objects, collecting that information, and exchanging data with other devices. So when your smartwatch reads your heart rate, it is connecting to your service provider's cloud and then making assessment about it. Similarly, there is huge industrial internet of things being implemented. This is one of the Gartner's matured, I would say, technology. So we need not go very detail on this, but you can check it out in other reference materials, and start implementing in your own factories or EPC companies or construction areas if you have not done already. So before we move on from a technology slide, uh, uh, I just wanted to give you some idea about what are those mature technologies. So when we researched, so mature technologies are cloud computing technologies, industrial robots, IoTs, and AI, 3D printing. They are some of the manufacturing. Sorry, they are some of the mature technologies. What as per the surveys conducted by various agencies, and technologies that are expanding is cyber security, augmented reality and VR, big data analytics. They are expanding. They are already matured, but they are also expanding. Where variables and sensors, they are also expanding hugely. Maturing are 4D printing, cyber physical systems, advanced human interventions. They are man machine interfaces. They are expanding. Some of the nascent, I would not call it a nascent, but quite an advancement is happening, but not at integration wise. So I would call it one of this is digital technologies, 5G, edge computing. Uh, Blockchain, I think it had a lot of promise, but I, not many surveys don't give them the practical, beneficial, I would say, matured rating to blockchain. So I would still give it in nascent. So these are some of the technologies which I can categorize from various reference from various surveys called matured, expanding, and still maturing, and nascent technologies. Okay, so we talked very in depth about technologies involved in uh, uh, sorry technologies involved in industry 4.0. Let me unshare. Let me unshare the slide and go back to our next topic. Okay, so interesting facts, right? We talked about 9, 10 technologies and industry got. However, more practically, when we are talking to each other and our professionals, we come across a lot of terms called what you call uh, digitalization, digital transformation. And I talked so much about Industry 4.0. Now, what is the difference between digitization, digitalization, transformation, and you know Industry 4.0? So let me give you a. I know we have been talking on this lot, and many people are maybe saying, "Oh, so this is so basic. Why you are covering this?" So, to be very honest, I'm covering this to the students and newbies in our industry. When the couple of matured or industry professionals are talking, we also need to educate our and newbies in our environment. So bear with me for this basic slide, which I'm covering at this stage, because after covering about Industry 4.0, then connecting to these technologies makes sense to the our. That's what I felt makes sense to the newbies, right? So let me tell you what is digitization. So this is basically converting an analog information into digital form. So if you are converting your scanned your Word file into a PDF, you are digitized. Okay. So if you are doing some manual work, if you are converting into digital work, digital information which you can store electronically, it is a digitization. Now, digitalization is applying digital technologies like automation, software, programming, data analytics to improve efficiency and accuracy of that stored information. So if you are using an accounting software, you are already digitalized. You don't need to include machine learning for digitalization, right? Okay. So when you are having a debate between yourself, let's have the context around it. Oh, guys. Okay. So let's move on digital transformation. And this is an interesting area. Digital transformation is basically fundamentally and basically change the way the business operates in delivering value using the digital technologies. This is how I would put it. Now coming up with new business models, products and services. That's really a digital transformation. So for example, if a newspaper company implements digital technology and goes online, and now their all business or most of their business comes from this online, then this is called I would call that as digital transformation. For an EPC company, there are already EPC examples of EPC company. Like whatever you did, apply the technology in your EPC sector and transform your industry. You are not no more just giving constructing a plant. You are constructing a digital along with a physical plant, also building a digital plant and giving it to the customer after while you integrate that with the customers ERP system, operation system. That is where you have transferred your business model. Or okay, let's stick to that example. So that's how I would call a digital transformation. For a process industry, if you actually implement end-to-end traceability and compliance of a process industry, that is how digital transformation I would call, right? Now, having said that, how does this technology industry 4.0 stacks up against this one? So, for me, so using using one of those technology, implementing for one of those specific use cases, and calling yourself digital transformed company may not no may not be really true into true sense. So, for me, if you ask me, the effort should be end to end. Start with small. Start small, scale big is my window. So industry 4.0 basically for me is the framework of digital transformation by implementing by integrating the advanced technologies. So I would put industry 4.0 stack up this along with digital transformation. Okay. So for the newbies, for the people who are trying to understand firsthand, so this is my definition. You can always go back more research and come up with your own, you know, your own definition of it. Right? Fantastic. So I'll take a pause here. Let's see what all we covered until now. So we started with definition. We started with the definition. We started with history. We reviewed its history. We reviewed its I would say popularity. We covered the technology components. We also engaged with ourselves with various definitions and various forms of industry 4.0. Right now, the last part I would say, I think another 4 or 5 minutes plus, which is more relevant to our own sector, our own country. So my podcast would be also focused on what we are doing as a country, right? So there are three distinct areas which I am going to cover in current state of industry 4.0 adoption in India. One is government policy decisions and their impact, skills and demographies, and current adoption scenarios. Okay, so these three areas which we are going to cover as part of our last section of this podcast. Okay, so under government policy decisions and their impact, let us look at two things. One is government policy, sorry, two things. One is Digital India Digital India and Make in India. Okay. Uh, okay. Under Digital India, if you say three things are we will talk quickly about, which is increased automation, improved connectivity, and e-governance platforms. So increased automation, digital technologies like robotics, AI are driving investments in modernizing, upgrading industrial processes, and there are a lot of investment. Already coming in this area. So in last decade, there is a huge improvement in automation in our country. Improved connectivity, I think we all talked about 5G rollout that is happening in India. A lot of digital literacy programs in India has started, so huge bump in that area also. E-governance, I think lot of government has bring in lot of platforms, process streamlining platforms for as part of e-governance. Now how it is relevant to a professional like us? See, still in India government is lot of, I mean, is a more investment or a driving investment driving force, right? And these e-governance will help most of us in getting a lot of quicker approvals, transparency, as well as it will bring in lot of skill set to the market, right? So that's how it is going to benefit digital. This Digital India is going to benefit us. Next one is Make in India. So as part of Make in India, let's just say this: 1% of GDP in last 1 year, gross value add has been done from manufacturing sector in last 5 years or 5 to 8 years, which is good. A country which is not known for manufacturing, right? So I am very optimistic about it. As well as there is a huge investment. I would call, just let me refer my notes, around 5 6 billion. I mean around 3 billion, 3 billions, 2 billions to 6 billion, around 4 billion FDI inflows happened in IT, information technology, with respect to manufacturing. Foreign direct investment has increased from 16.5 to 83.5 USD, which is five-fold increase. So, increased funding, FDI increase, and growth in manufacturing. These three have happened in Make in India. And before I move on, there is a huge steady and government push is happening with a lot of universities, industry collaboration, not only government, is happening in manufacturing sector and industry 4.0 adoptions in India. So I think this is the impact of Digital India and a lot of government push that is happening. So that's a good sign for industry professionals as well as technology owners and owner operators. Okay, let's move to the next topic, which we called about skills and demography. Very interesting, and I am not an expert in this technology, so I am referring various IBEF surveys, consumer pyramid household surveys, and various surveys published elsewhere, right? So these are not my numbers. Okay. uh, so three parameters I would tell you. One is 60.6, around 60% of working population has around 10 to 12th grade education. 12% have attained more than have has a higher degree, a degree education. First number. Second, around 25 to 30% is women in our industrial workforce, and it's still around 70% is male dominated. Older workers are 35 and above, so not so old, but still they are old. Younger workers are 18 to 34, fantastic, and they contribute around 30% of the age group, and they have all those undergraduate degrees and higher than this. And this trend is seen to be increasing. More and more women are entering our workforce. More and more younger generation entering our manufacturing and EPC workforce. Median age of industrial workforce is around 28 years old. Fantastic. All these numbers are great if you ask me. Yes, the education level is slow, and last 10 years it has taken up. Now with lot such investments, such initiatives, I think this is going to only increase. So if you look at the future, uh, the the demography is as our country in all our areas, this is huge, right? This is beneficial or in a positive side. Skill set wise, what should be the skill set if you are going to adopt these industrial technologies? So if you actually see, I mean, technical, we already seen all those technologies, right? But still, if you only talk about soft skills under this right now, I would think many people are talking about critical thinking, problem solving, adaptability, and lifelong learning, because these things are changing every day. That I mean, who had thought chat gpt is going to change so much narrative around us? So right, and we are all trying to learn what is this disruption has done to us, right? So we need people who are lifelong learners and who are adaptables. And emotional intelligence is going to be a lot more important going forward, where there will be a lot of human machine interactions, so a lot of, yeah, I mean, isolated human interaction. So I would feel emotional intelligence is going to play a lot of areas. Okay, so uh, current investments in India, if we would like to summarize, so lot of investment has done in proven technologies, rightly so, which is cloud, IoT, big data analytics, connectivity technologies like connecting the factories, connecting the industries, robotic process automation. I'm not sure how many EPCs have done it, and process industries have done it, but as a in technology, this has a huge investment has taken place. Okay, uh, and it's a worth technology to look at it. So lot of investment is still happening, and 50% of investment is in IoT is what the surveys tell us, right? But and sorry, and supply chain logistics are value added, I mean, are the value proposition sectors where a lot of investment has happened. Okay, but emerging technologies such as AI, ML, forget Gen AI, but this data manipulation, data transformation technologies are still, looked at more POC or POV level. I think this trend is going to change, but this is what the current adoption in industry is. Okay, uh, so uh, what are the timelines and returns on returns if you are adopting these technologies and trying to uh, trying to see what is the benefit I'm going to get by implementing this? And this is going to be my last topic which I'm going to cover and in couple of minutes. So uh, uh, again, I'm going back and referring to the NASCOM survey, which you all can go back and review, which clearly points out a lot of other than this information. So if your use case is around production to ROI, so if you are implementing something and you are quickly expecting a ROI, then the timelines reviewed by, I mean, timeline benchmark is around 12 to 18 months. Okay, and if you are looking at use cases which is around supply, demand, and predictability of this logistics supply chain, around 2 years, and that's a fact. Okay, this is a benchmark what industry people have done. And if you are specifically looking at warehousing, store management, logistic, which has a very quick turnaround, implementation of Industry 4.0, which is around 12 plus months. I would say still 12 to 16 months still. Okay, because a lot of proven technologies are behind. And if you are an industry owner or a technology manager, if you are looking at end-to-end traceability of the traceability and compliance related use case, I think you should keep it around 36 to 48 months, or that is around 3 to 4 years. So what is the outcome? Summary I'm going to tell. If you are a technology manager and a digitalization expert and you are a digital transformation leader, and if you are promising something to your organization or management, keep these timelines on mind, because these are the benchmarks in the industry. And also look at the technology you are implementing and particular use case that you are going to implement. And if you are a owner operator and looking at end-to-end traceability, have a good long-term view of your digital transformation journey, industry 4.0 adoption journey, and as I say, start small, scale big, rather than directly going for some use case which is going to give you a traceability end to end and compliance related use case, and then losing focus after 1.5 years because you are not getting the right results out of your industry 4.0 journey. Okay, so with this information, I wanted to end this podcast, which is Industry 4.0 Unplugged, uh, Industry 4.0 Basics. Okay, I hope you guys enjoyed this journey of origin, history, terminology, technology, and our own adoption scenario, and what we should look in terms of returns. And I really enjoyed collecting all this information. Soon I will also floating an article around this topic. I hope you all like it, and please directly reach out to me if you have any concerns, questions, and all this again around all this information which I have presented. Okay, and before I end, the one small disclaimer: this is a personal endeavor where I want to democratize the information, collect the information, and share the information. The context, the content, and the referencing distribution, everything is my responsibility. The employer or anybody will not have any not responsible for this content, and I would take all legal responsibility of this topic. So please consider this as disclaimer while you review this material. And as I honestly said, I have collected this information. I have tried to give my reference wherever possible. If I have missed, and if you find this information is related to any of your own research area, please come forward and inform me. I will be happy to publish this information. There is no commercial interest on this topic. So the only interest is to distribute the knowledge and share the knowledge. So please come forward. Let's make the information more democratic and more more democratic, I would say. Okay, so until I publish the next topic, please take care. Thank you. Please visit the channel, and also come back and review these technologies. Go forward and understand and implement your own factories, your own EPC world and construction sites. Okay, thank you. Thank you very much, and all the best for your implementation use cases. Thank you. Bye bye. Take care.